Hello, and welcome to LinMot Tutorials. In this video, we will demonstrate how to size the z-axis of an XZ pick-and-place. We will begin by going to Global Settings and enter the application load data. The tooling mass in this application is 2,000 grams. This version of LinMot Designer has moving mass of our motors and guides. Therefore, we select the vertical down as a motor's orientation. Next, we select the H-guide by going to the motor, select the motor type, linear motor with H-guide, HML1 group, and the family of, we initially stay with 37 by 120, as it is the default. The guide selected has a maximum stroke of 80 millimeters, which fits our application. Cables are selected according to the motor and drive type. Here we select the K15 4 meter. We will uncheck and add typical supply capacitance because we will be using our standard 120 volt power supply, which has a 390 microfarad external capacitance. Next, we'll start building the motion profile. Double-click segment 1 to edit the parameters. It will be a sine move with a stroke of 70 millimeters and a time of 300 milliseconds. Click Add a new segment. Segment 2 will have a stroke of negative 70 because we are retracting back to 0, and a time of 300 milliseconds. In the local load settings, we add 500 grams to the mass for the part that is being picked. We can ignore the thermal loading error until our motion profile is completed. Segment 3 will have the local mass of 500 grams for the part that is being picked up. We will change the curve type to a standstill, and the motor will be at rest for 500 milliseconds. Segment 4 will be the same as segment 1, except it has a local mass of 500 grams for the part picked. Right now we have an end position error. We can ignore that for now because it goes away after the next segment has been created. Segment 5 is the same as segment 2. But the part has been placed so the local mass can be removed. Segment 6 is another 500 millisecond standstill. Notice that we have thermal issues with this motor. The way to fix this issue would be simply changing the cooling method from flange to fan. Selecting the fan will make the thermal loading go away, but in this example we will use a mag spring because it requires no power, wires, and it is also efficient in holding the slider in a vertical orientation. To size the mag spring, click on Global Settings. For the external force, add negative 40 newtons. The external force is negative because the orientation of the motor is vertical down and the mag spring is pulling the slider. And add the mass of the mag spring slider to our overall mass. On the datasheet shown, which will be provided on the description below, this mass of the slider of the mag spring is 155 grams. So 2,000 plus 155 would be 2,155 grams. The thermal load is now 16%, whereas before it was over 100%, which was giving us the thermal error. Since this will be the z-axis in an XZ pick-and-place system, the x-axis will need to move the whole system. It will be best if we can use a smaller motor and reduce the overall mass of the z-axis. Go to our global settings. We will choose 23 by 160 motor variant, high performance. We will then select high performance variant with a stroke of 80 millimeters. No warnings appear with the smaller motor selected. The 40 Newton max spring still works and has enough force to keep the picked part from dropping in a power failure situation. We use peak force value to check with the friction in the Global Settings tab. Quickly check to see if the part is prevented from dropping in a power off situation. Look at the peak force, which is 12.8, and subtract the friction, which would be 7.8, which is still a positive number, whereas the force is enough to keep the picked part from dropping in a power failure situation. This concludes this tutorial. Thank you.